Hi class, this is Professor Lindemeyer for your Test 2 review for college algebra. All right, let's get started, and we're going to go through these 9 problems together, and just keep in mind that this is not a comprehensive test review. It's just like a snapshot of the concepts that we discussed in class last time, and you should look to other resources as an avenue of study. Go back in my math lab, review past homework, and use the class notes as well as a source of study. All right, so again, this is not comprehensive, and you should utilize other resources. Okay, all right, so number 1, it says use the graph to answer the following, and if it does not apply, write NA, not applicable. So here we have a graph of a function, and we want to figure out these properties in this chart. Okay, so just keep in mind that this is a continuous arrow at both sides. It didn't print that way, but there's arrows going in both directions. All right, so domain, recall that the domain is the allowable x values, right? So we're gonna look left to right on our graph, and we see that it goes to negative infinity to the left and positive infinity to the right. So that's our domain for this function, and we're doing interval notation. So we need to put parentheses on either side when we deal with the infinity symbol. For the range, that's our allowable y value. So we're going to look up and down to see how far the graph goes. So how far down does it go? Well, we see it stops at 0. How far up it goes, we see it stops at 6, right? So we're going to go 0 to 6. And because we're including 0 and we're including 6, we're going to put brackets around both. Okay. All right, next we're talking increasing, decreasing, and constant intervals. Now these intervals are always going to be in parentheses, and we're just looking at the x values, right? The horizontal direction. So looking left to right, where is our graph increasing? All right, we read left to right, so we're going to look at this graph from left to right. So we see the graph increases from 0 to 6, right? So we're looking at the x value. So 0 to 6, it's increasing. All right, so that's our increasing interval. All right, where is it decreasing? So from left to right, it is decreasing from -3 to 0, right? It's going down, -3 to 0 on the x values. Again, we're going to use parentheses here. And where is it constant? Where it's constant in 2 places, right here and right here. So what are the intervals for these 2 portions of the graph? Well, the first interval is going to be negative infinity, right, to -3. Negative infinity to -3. And also from, looks like 6 here, to positive infinity. So from 6 to positive infinity, the graph is constant. And there we go. All right. So those are increasing, decreasing, constant intervals, and you need to, again, just look at the x values in the from left to right and indicate that here. All right. All right. What values of x is their relative minimum? So relative minimum is like going from decreasing to increasing. So where do we see that? We see that right here, right? So at this x value, so it goes down and then up. So a valley is our minimum. So what value of x is their minimum? We see it is at the origin, so when x is 0. Now, where do we see a maximum? So we're looking for a hill. So there's no hills on this graph, right? We need to go from increasing to decreasing. So nothing like that is on this graph, right? All right, so this is not applicable. All right, so that covers question 1 and identifying certain properties by looking at the graph. All right, moving on. Let's go to question 2 now. So question 2 says, determine whether the function is even, odd, or neither. So when we talk about even and odd functions, let's remind ourselves what that means. So even means it's symmetric about the y-axis. So there's like a mirroring going on about the y-axis. And then odd means it's symmetric about the origin. So we think of odd, you think of the cubic function. Even we think of the parabola or the x squared function. So in order to figure this out, we're going to replace negative x wherever we see an x. And if after doing so, we get the same function back, that's an even function, right? If after replacing the negative x wherever we see an x, we get the opposite of the original function, that's going to be an odd function. If none of those two circumstances happen, then our answer is neither, okay? So let's replace negative x wherever we see an x. All right, negative x to the third power is negative x cubed, right? Because negative 1 to the third power is a negative 1. And then you have negative 5 times negative x, that's going to be a plus 5x. So we see here that when we replace negative x, we get negative x cubed, so the opposite of this, and then plus 5x, so the opposite of this. So we see we get the direct opposite result. So by comparison, we have an odd function. So if we got this same function back after replacing negative x, we would call this even. So if this was x cubed minus 5x, then we would call it an even function. Since we got the opposite of our original function, right, all the signs changed, we have an odd function. Okay, if neither of those two circumstances occurred, then we would say neither. Okay. All right, now that we've done 2, we're going to move on to the next page and do number 3. Okay, so question 3 is graphing a piecewise function. So remember, a piecewise function is a function that is kind of like a compilation of different equations that are specified over certain domains, and that they together create this piecewise function. So our first objective is to graph x plus 4 in the domain between negative 8 and 3. So let's think about this. So I'm going to create an x and y chart just to help me figure this out. So if we only need so I'm just going to use negative 8. We only need a few points to graph this portion of the function. So negative 8 to 3. So I'm going to use negative 8, and then I'm going to use 3. So when I plug in negative 8, I get negative 8 plus 4. Negative 8 plus 4 is negative 4. When I plug in 3, now 3 is not included in here, so we know it's going to be an open circle. So you may want to put like a note open next to it. When I plug in 3 here, I get 7. All right. Then I know at 3, I get a closed circle for negative 9. So when I plug in 3, I have just like a closed circle. So that's just a point, the point 3 comma negative 9. And it's a closed circle. And then if I plug in 3 here, again, 3 is not included. It's x has to be greater than 3, but we can get really, really close to 3. So we're going to put an open circle for this part of the function. So when I plug in 3 here, I get negative 3 plus 7, which is 4. But we're going to again put an open circle here, because we're not including it. So we're not including it here, and we're not including it here, but we need to plot it because we get close to 3 in both parts of the graph, but we never actually touch it. So we put an open circle. Now I need another point for this part of the graph. So I'm just going to do just gonna do 4. That seems easy enough. So -4 plus 7 is 3. So now that I got my points, I'm going to graph each segment of this piecewise function. So -8, -4, that's gonna go, here's -8 and down to -4, so that's right about here. All right, 3, 7. So here's 3, I'm gonna go up 7. And then I need to connect, but I need to make this an open circle, so don't do what I just did. All right, that's gonna be an open circle, so I need to connect the dots here. I forgot my ruler, so hold on for a second. All right, so let's connect these dots. It's gonna be my first line here. All right, so it's gonna look something like this. All right, so we're gonna include -8, so closed circle at -8, open circle at 3, because we approach and come close to 3, but we're not including it, right? All right, then we have a point, so we might maybe identify that as a point. Point at 3, -9, that's what that is. So we're gonna go to 3, and we're gonna go down to -9, and just plot that point. So that's all, that takes care of that piece, okay? And then we want to graph this aspect. So at 3, again, we're going to get an open circle at 4. So here's 3, open circle at 4, so something like that. And then we want to plot 4, 3. You can, that was just another point that I chose, but you don't need to actually choose that. So here's 4, 3. And just for good measure, let's just do another one, like something closer over on this side. So I'm going to choose 10. At 10, right, we're in this camp. -10 plus 7 is, -10 plus 7 is -3. So we need to go down to -3 here. And I'm just doing that so I can get an accurate depiction of where this line's going, because I know it's going this way, right? So here's 10, I'm gonna get -3, so something down here. And it's just a line that's gonna continue and going off this way. Okay, so let me put that on here. All right, so it's like a ray. Okay, so this is a line segment because it only goes from -8 to 3. Here, this goes from 3 all the way to infinity, right? And then here's the single point at 3, -9. And that's how you would do it. Okay, so this covers the first part. This covers the point. And then these 3 points help us get this ray. Okay. All right. Hopefully that made sense. And if it doesn't, you can email me and we can talk about it. All right, number 4. So number 4 says use the given conditions to write an equation for the line and slope intercept form. Let's remind ourselves what that is. That's this. So again, you guys got to memorize slope intercept form. You need to memorize point slope form, general form, what that looks like, because I'm not providing that to you. There's no formula sheet for this test, so you need to come with your memory and be able to recognize what that means. And yeah, and you can put it on your scrap piece of paper, but you have to do that during the test. You can't have it pre-written on your scrap sheet of paper. That would be cheating. But once you have your scrap sheet of paper and you start your test, you can write these things down if you don't want to, if it helps you to have that as an easy reference while taking your test. But don't come in to the exam having it pre-written on your scrap sheet of paper. Okay? All right, so here we're given 2 points. We want to create a line. We know we need, to put it in slope-intercept form, we need to find the slope, right? So we need to figure out the slope of this line. We're given 2 points, so we know what that means. We need to do this equation. Again, another equation you need to memorize. Okay, I'm gonna call this x1, this y1, this x2, this y2, and then plug and chug, and you should be good to go. So here we have -8 minus a -3. Then we have -4 minus a -8. All right, and we know -8 minus a -3, that becomes a plus, so -8 plus 3 is a -5. -4 plus 8 is a +4, so our slope here is -5/4. Now, in order to put it in slope-intercept form, you need to have B here. We don't have B. So there's a couple of ways you can go about this. One way is to plug the slope here and use X and Y from either one of these 2 points. Plug them in here and then solve for B. You could do that. Or you can go straight into point slope form and then rearrange it and solve for Y, so you can get it in slope-intercept form. So that's kind of like the route I want to take, but if you want to take the previous route where you plug everything into this equation and solve for B, and then once you get B out, you can rewrite it in slope-intercept form. You could do that too, but I'm just going to go straight into point slope form. So point slope form, recall that's this. Again, another equation you need to memorize. So I'm going to plug in x1 and y1 from here. You could also use this point if you want, but I'm just going to use the first point, and then I have my slope, and then I'm going to rearrange and solve for y. So that's my strategy here. So I have y minus y1, so y minus a -3 equals -5/4 times x minus a -8. So this becomes y plus 3 equals -5/4 x plus 8. Again, we want it in slope-intercept form, so I'm going to rearrange and solve for y. So first thing I want to do is distribute this -5/4 everywhere. When I distribute the -5/4 to the 8, this is like 8/1, if you can imagine, right? So it's -5/4 times 8/1. 4 goes into itself 1 time, 4 goes into 8 2 times. -5 times 2 is -10. And now we're going to subtract 3 from both sides. So we get y equals -5/4 x minus 13. So there it is in slope-intercept form. And we accomplished our objective, right? So like I said, I think this is my preferred route to go, but you could also plug this in to slope-intercept form, plug one of these points for x and y, solve for b, get -13 out, and then rewrite it to look like slope-intercept form. Okay? All right. So that's done with question 4. Let's move on to page 3 and do question 5. So here's page 3, question 5. Graph the linear function by plotting the x and y intercepts. So I dictate to you how I want you to graph this. Of course, there are other ways you can graph this function. You can convert it to slope-intercept form and graph the y-intercept, and then use the slope to generate your next point and connect those 2 dots. And you can also create an x and y chart and generate random points and do it that way. But I told you, let's do it the x and y intercept method. I personally prefer this method. So if you can nail this down for the test, that'd probably be a good idea. All right. First thing is we want to recognize what an x-intercept is. So an x-intercept crosses the x-axis. So if it crosses the x-axis, the value of y is 0. So if I plug in 0 for y, what do I get for x? So let's imagine if I plug in 0 here, I'll have negative 1/2 x minus 4 equals 0. So if I solve for x here, I get negative 1/2 x equals 4, right? Move this guy over. And now I'm going to divide by negative 1/2, which is essentially multiplying by negative 2, right? Because it gets rid of everything. So multiplying by negative 2, you get x equals negative 8. So here, my x-intercept is negative 8, 0, okay? Likewise, if we want to figure out our y-intercept, we know that occurs on the y-axis. The value of x along the y-axis is 0. So I want to plug in 0 for x and figure out what y is. So if I plug in 0 for x here, the equation becomes y minus 4 equals 0. Therefore, y equals 4. So my y-intercept is now 0, 4. Okay, so we have 2 points. Let's plot them, and then we can connect them with a line. So here's 0, here's 4, here's negative 8, here's 0. And now I want to connect a line between them, a line that runs between them. So again, this is just a sketch. You're going to do everything on the MindMathLab graphing tool. So something like that, a little off, but that's good. All right. So that's how you graph this line using x and y intercepts. Pretty straightforward, I think. Okay, let's go on to question 6. So question 6 is using the given conditions to write an equation of the line in the indicated form. So we want it in slope-intercept form and general form. So we want to practice both of those. So this line passes through this point 5, 3, and it's perpendicular to the line whose equation is this. So if our line contains this point and is perpendicular to this line, well, this line has a slope of 1/7, right? So our line, so I'm just call it M1, or we could say M perpendicular, that's like the symbol for perpendicular. Our slope has to be the negative reciprocal of that, which would be -7. So right, flip and then take the opposite sign. So our slope is -7 for our line. So now that we know that, we need to figure out it in slope-intercept form and general form. So here we have a point on our line. Here we have the slope of our line. That tells me let's go to point-slope form. So again, point-slope form, we're going to go y minus y1. y1 here is 3, x1 is 5. So y minus 3 equals m, -7 times x minus x1, which is 5. So that's point-slope form. We want it in slope-intercept form. So let's move everything around so that we get y by itself. Distribute the -7 first. So we get add 3. So we get y equals -7x plus 38. So that's it in slope-intercept form. So I'm going to just write that down here. All right, so slope-intercept form is y equals mx plus b, and we got that. So if I want it in general form, so general form, we're going to do ax plus by plus c equals 0. So that's what general form is. So we want to get everything over to one side. So we want to lead with x, then y, and then the constant term. So you can either move the y over here or move both of these over this way. I'm just going to move the y over. It's one thing to move over. So we get 0 equals negative 7x, and I'm going to put it in this order, right? I'm going to put the y next, so it's going to be a minus y when we move this over, and then plus 38. So you can write it as negative 7x minus y plus 38 equals 0. And remember, if you move this over here, then it would be 7x plus y minus 38 equals 0. So both of these are acceptable. It just depends whether you move this guy to the left or move the y over to the right. Okay. And my math lab should recognize both versions. Okay. All right, so that's number 6. Let's go to page 4 and tackle number 7. Okay. So here's number 7. So this number 7 is this transformation problem. So it says start with the parent function, right? Our parent function is x squared. And then use the transformations to graph this guy. So I've already provided for you, for just ease of explanation, the x and y chart for the parent function. So just recall that if we plug in negative 2 here, negative 2 squared is 4. So that's how we got there. Negative 1 squared is 1. 0 squared is 0, right? And 1 squared is 1. 2 squared is 4. You get the idea. So that's how I generated these ordered pairs, okay? So that's our parent function. Now we're going to apply these transformations to see how it changes our x and y values, right? So I told you in class you're going to work inside out. So we're going to start closest to the x and then branch outward, okay? So the first thing we notice closest to the x is this minus 5 here. So this minus 5, if you recall, is a horizontal shift to the right 5 units, right? So just remember, if it says negative 5, you're going to move to the right 5. If it's at plus 5, it would be moving to the left 5. So if you're moving horizontally left to right, here to the right, you're changing the x value. So we're not even going to touch the y column. We're going to manipulate the x column. So I'm going to call this new column x prime, this little x apostrophe, to denote that I'm changing the x values. So if I'm moving to the right 5, I'm going to, like if you're moving right, you're adding, right? So I'm going to add 5 to each of these x values. So when I add 5 to negative 2, I get 3. To negative 1, I get 4. To 0, I get 5. To 1, I get 6. To 2, I get 7. Okay, so our new x values are 3, 4, 5, 6, and 7. All right, adding 5. All right. Okay, so that takes care of the right shift. If you want to put that here, right shift, to help you. You don't need to. All right, now let's tackle this negative 1/3. So a few things. This, the negative is a reflection over the x-axis, right? So it's actually, this is our outline of our parent function. So what are we doing? We're flipping it down. It's a reflection over the x-axis because it's a negative on the outside. If the negative was inside here, it would reflect it this way, okay? But since it's on the outside, it's reflecting and pretty much making the upward-facing parabola a downward-facing parabola. And then this 1/3 is a vertical stretch, right? Because it appears again on the outside. So the 1/3 is a vertical shrink rather, because it's less than 1. It's less than 1. But you don't really need to know the names of all this. You just need to know how it changes either your X or Y values. So since this is a vertical stretch or shrink, specifically it's a shrink because it's less than 1. Again, you don't even know that. Just identify as a vertical stretch shrink. You're going to multiply vertical shrink. You're going to multiply your Y values. Since it's a vertical shrink rather than a horizontal shrink, you're going to multiply your Y values by 1/3. And since we're doing this reflection, I'm just going to multiply my Y values by -1/3 so we can capture the reflection transformation as well as the vertical shrink. So you can do it all in one step, okay? So again, vertical shrink, we're not touching the X, we're touching the Y's. So I'm going to multiply all my Y values by this -1/3. Okay? Okay, so 4 times -1/3 is going to be, again, right, Y prime. Okay, so 4 times -1/3 is -4/3. 1 times -1/3, again, is -1/3. 0 times -1/3 is 0. And 1 times -1/3 is -1/3. 4 times -1/3 is -4/3. Okay. So again, we just multiplied all the Y values by this -1/3. All right. The last thing we have to address is this +3 on the outside. Okay. So we're gonna add 3 to the Y values because this is a vertical shift up. 3 units. Okay, so again, if it's a shift up, we're not touching the X values. We're going to manipulate the Y values, but we're manipulating these new set of Y values, right? So I'm going to add 3 to all of these. So you may need the help of your calculator to do this, which I'm going to do. So I'm going to call this Y double prime. And I'm going to add 3 to all of these. So adding 3, just to illustrate for you, if I want to add 3 to fractions, you need a common denominator. So adding 3 is like saying adding 3 over 1. So I need a common denominator, that's 3, so multiply by 3 over 3. So you're going to essentially be adding 9 over 3 to each one of these, okay? So if I add 9 over 3 to -4/3, right? -4 plus 9 is 5/3, right? And then -1/3 plus 9 over 3 is 8/3. This is just straight up 9/3 or 3, right? And -1/3, again, it's going to be 8/3. And -4/3, again, is 5/3. Okay. So let me just confirm I'm doing everything right here. All right, so these are our X values, these are our Y values, and now we want to plot this down here. Okay, we want to plot these points. This 5/3, if you put it in your calculator, it's going to be like 1.6666. So we're just going to call it 1.67. And if you put 8/3 in your calculator, that's going to be 2.67-ish. And then same thing here. So you got an idea of what that is in decimal form. All right, so here's our new X values. These are our Y values. So we need to graph these and then connect it with a smooth curve to create our parabola here. So here's 3. I want to go to a 1.67. So again, that's going to be a little off. So here's 1.67. We'll just put it between 1 and 2 there. At 4, I get 2.67. So again, it's between 2 and 3. So we'll just put it like that. And at 5, I'm going to get 3. So it's like that. And then same thing with 6, we're going to get 2.67. So like that. And then 7, we're going to get 1.67. So like that. So you see how it's like a mirror image going on here. So we know it's doing something like this, right? Again, this is just a sketch. Something like that. We just need a sketch of what's going on. So we see it's upside down. It's been shifted to the right 5, and it's been vertically shrunk. So there you have it. We just need a general idea of how it looks. So this is how it looks. And of course, if you want to like play around with the numbers to generate more points to get a more accurate idea of what's going on below this x-axis, you can just put in points here. You want to put in 2 here, 2 minus 5, square it, multiply by -1/3 plus 3. You should get 0 here. And then same thing with 8, you should get 0. And you can continue to put in points and see and plot further down. Not necessary for you to do that. You can just use what we got here and connect these points with a smooth curve, because you just need a general idea of what's going on. Okay, hope that made sense. And I know we don't like fractions, but convert them to decimals and kind of guesstimate how to plot them here. Okay. All right, let's go on to question 8. So it says, find the domain of the composite function f of g. So the first thing we need to do is create the composite function, and then from there, identify the domain. So here we're going to plug g into f, right? So it's f of g. So wherever you see an x in f, you're going to plug g. So let's do that. So f of g of x, we're going to plug in g into f. So we have 8. My 8 over x is going to go here. So we have 8 over x plus 8. I want to clean this up because that looks nasty. I want to make it like a nicer looking fraction, not a fraction within a fraction. So let's try to reduce this denominator here. So if I'm adding 8 over x plus 8, this is technically adding 8 over 1. Our common denominator here is x. So we have 8 over x plus 8x over x, right? And if I write this as one fraction, I have this. So this becomes this, right? Because I want to write it not as 2 separate entities, but as one. So I have 8 equals 8 over 8 plus 8x over x. And every time you have a number divided by a fraction, you're going to flip the fraction and multiply. So we have 8, I'll just call 8 over 1. And then I'm going to flip this and multiply it by 8 over 1. So I'm going to have times x over 8 plus 8x. This is just how we simplify and how it's expressed on paper. This is all just kind of mechanics for how to make this look nicer, okay? So we have 8x over 8 plus 8x. So this is our f of g function here. So I'm going to call that f of g of x. All right, now we have our function for the composite. I need to figure out the domain. So in order to know what the domain is of our composite function, we have to know the domain of the function we plugged into, right? So we plugged g of x into f of x. So the domain of g of x we know cannot include 0 because that's going to make our denominator 0, right? Anytime you're dealing with functions with fractions and you have x in the denominator, you need to figure out what value of x is going to make your denominator 0. Here, 0 is the value of x that will make this denominator 0. So we exclude that because we can't divide by 0, right? Okay, so you only need to know the domain of the function you substitute into the other function. So I'm not concerned with the domain of f. I need to understand the domain of g and then combine that information with the domain of f of g. So here, f of g, what value of x is going to make this denominator 0? If you can't see it right away, you just plug this, set this to 0, and solve this equation. So you get 8x equals negative 8. So x equals negative 1. So negative 1 would make this denominator 0. We don't want to include negative 1. Okay, so we don't want to include 0 for the domain of g, and we don't want to include negative 1 for this composite function. So our domain overall has to be taking this into account and taking this into account. So if we imagine our number line here, here's negative 1, here's 0. We don't want this one, we don't want this one, because 0 will make my g function not acceptable because we can't divide by 0, and negative 1 will make this function not acceptable because we'll divide by 0 down here. So everything else on this number line will be okay. So how do we put that in interval notation? Well, everything to the left of negative 1 is okay. So negative infinity to negative 1 is going to work. And we don't want to include negative 1, right? So we put the parentheses. Everything between negative 1 and 0, so you can imagine like negative 0.5, negative 0.8, that's going to work. So we're going to say between negative 1 and 0, don't want to include either one, so we put parentheses. And everything beyond 0 is going to be okay. So 0 to infinity. So this is our domain here. So it takes into account exclusions for the g function and then exclusions for our overall composite function. Okay, and we need to know both for the domain of our composite. Okay, all right. We don't need to know the domain of f, just we need to take into account the domain of g and then our final domain for f of g. Okay. All right, that's number 8. One more question to go and then we're done. So question 9, we're going to go on to the next page. So question 9 says graph the function f as a solid line and its inverse f negative 1 as a dashed line in the same rectangular coordinate space. Use interval notation to give the domain and range of the original function f and its inverse function f negative 1. All right, so just recall that a function and its inverse, the x and y's are swapped. So to figure out part A, the inverse function, we're going to need to swap x and y and then solve for y. So f of x is our y, so we can replace f of x with y. And now we want to interchange x and y, so I'm going to say x equals y squared minus 7. And then I want to solve for y here. So x plus 7 equals y squared. Now I need to take the square root of both sides. So when I take the square root of both sides, I get the square root of x plus 7 equals y. Now, now we have to figure out the domain and range of f of x. So the domain is already stated here. This is the domain for f of x, our original function. So if we put this in interval notation, it's 0 to infinity, right? because x has to be greater than or equal to 0, so it's 0 to infinity. So I already know off the bat that that's what my domain is. Now, I said f in its inverse, x's and y's are swapped. So the domain of the original function becomes the range of our inverse function because of that swapping property. So we know that our range of our inverse is exactly the same as our domain of our original function. Now what's left to do is figure out the domain of our inverse function. So this is our inverse function, right? So after we do this swapping and solving for y, we rename y f inverse. So we need to figure out the domain here. And remember, we're dealing with a square root function. So I taught you in class to figure out the domain of a square root function, you're going to take the quantity inside and set up this inequality. Remember, because square roots can only be positive, right? So we only want positive numbers inside our square root. We can't take the square root of a negative number. So you're going to set this quantity to be greater than or equal to 0, which means it has to only be 0 or positive numbers inside the square root. And if you solve this, right, subtract 7, you get x has to be greater than or equal to negative 7. So what is this in interval notation? Well, that's negative 7 to infinity. So this is our domain of our inverse function. So that's going to go here. And like I said, the domain of our inverse is our range of our original function. So we're just going to label that like such. Okay, so again, these are swapped because x and y are swapped. So the domain and range are swapped between the original function and the inverse function. So all you have to do is identify your domain for the original function, identify your domain for the inverse function, and recognize that the domain of one is the range of the other, and you're good to go. All right, all that's left to do is to graph both functions. So recognize that up here we said our original function has to cover x values from 0 to infinity. So I'm just gonna create an x and y chart here. So here's x. I'm gonna call it y f of x so we can distinguish them. So when I plug in 0, 0 is my minimum, right? That's where I start. That's my starting point. When I plug in 0 for x, I get negative 7. If I plug in 1, right? 1 squared is 1. 1 minus 7 is negative 6. And let's just keep it going at 2, right? 2. 2 squared is 4. 4 minus 7 is 3. And you can keep generating points if you'd like. Let's just do that. Let's do 3. 3 squared is 9. 9 minus 7 is 2. So now we can connect with a smooth curve these points, right? So it starts at 0 and you can only go up, right? I can't plug in negative 1 because that's outside my domain. Okay, so I start with 0 and I choose x values greater than 0. So here's 0. Here's negative 7 down here. Oh, here's 0, negative 7 right there. Here's 1, negative 6, so we're doing that. 2, 3. So up here. 3. Oh, sorry, didn't I? Plug in 2. 2 squared is 4. 4, oh, so negative 3. My bad. I should say negative 3. So 2, negative 3. Oh, that does not look right. And then 3, 2. So ignore that. 3, 2. So we have this type of action going on. So it's like half of a parabola, right? which makes sense because we know it should look like a parabola, but we're only doing half of it because we only want positive values for my x, 0 and positive. All right, so that's the solid line. That's f. That's our original function. Now let's graph the inverse function. So I'm just going to use a different pen. You can do a dashed line, but I'm just going to use a different colored pen. So I'm going to create a new x and y chart for my inverse function. So we know our inverse function's domain here is -7 to infinity. So I'm going to start with -7 and then do -6. So -7 plus 7 is 0. Square root of 0 is 0. Right? -6 plus 7 is 1. Square root of 1 is 1. Now I'm going to be choosy about what my next value is going to be, because I want to choose values of x that are going to give me clean results. So I know what would make this whole thing 4, because I know the square root of 4 is 2, right? So if I plug in -3, I get -3 plus 7. -3 plus 7 is 4. Square root of 4 is 2. So that was just a clever way to like generate points that are nice and clean. And you can figure out another number to plug in here to get like 9. So what number plus 7 will give me 9? We know that's 2, right? 2 plus 7 is 9. Square root of 9 is 3. So I have these. Now I'm going to connect them with a smooth curve. So here's -7. Here's 0. Here's -6. Here's 1. Here's -3. I gotta go to 2. And at 2, I get 3, which is the number I tried to erase, right? So it's gonna look like, if we want to keep it as a dashed line, something like this, right? And that makes sense because it should be symmetric over the y equals x line. So remember, the y equals x line is just a line that like divides the graph through the origin. So this is a y equals x line. And we see that it's symmetric. So if you, this is your original function, if you were to like mirror image it, I'm creating my own vocabulary, its mirror image is appears over this y equals x line, which is its inverse function. So we know we did it right, okay? So let me just recap this so it makes sense to you. So the first thing you want to do is figure out your inverse function. In order to do that, you're going to swap x and y. So we're going to plug y here and x here, and then you're going to rearrange and solve for y. So when you do that, you arrive here, and now we're going to relabel y our inverse notation. Next, we have to figure out the domain and range. So the domain is already given for our original function. That's here. So we just have to put in interval notation. So that's 0 to infinity, and we're going to include 0. To figure out the domain of our inverse function, recognize that we're dealing with a square root function, and only positive values in 0 can go inside the square root, right? You can't take a square root of a negative number. So we're going to create this inequality. So x plus 7 has to be greater than or equal to 0. Solve this inequality, we arrive here. If we put this in interval notation, we get this. So this is our domain of our inverse function. This is our domain of our original function. So that's here and here. And we know the domain of our original is the range of our inverse. Likewise, the domain of our inverse is the range of our original. So that's that property, that x and y's are swapped, therefore the domain and ranges are swapped. And then we graph these two on the same rectangular coordinate plane here. And how did I generate these values? Well, I recognized that the domain for my original function has to be 0 to infinity. So I started with 0 and just chose numbers greater than 0 to help me get an idea of how the graph should look. So I plugged in 0, 1, 2, and 3 into the original function here. And likewise for the inverse function, I know that the domain is -7 to infinity, so I got to start at -7 and work my way up. So when I started at -7, I got 0, and then I'm trying to be clever and choose numbers for x that work well in the square root. So I want to get like nice square root values out. So I know if I plug in -7, I'll get 0, the square root of 0 is 0. If I plug in -6, I'm going to get 1, the square root of 1 is 1. And I want a square root that is something that I recognize. So I know the square root of 4 is 2. So what's going to make this square root of 4? Well, if I plug in -3 for x, I get -3 plus 7 is 4. Square root of 4 is 2. And I know what's the next square root. I know from the top of my head, I know the square root of 9 is 3. So I'm going to plug in 2 for x here and get 3. So I chose 4 points for each set here. You can do more or less. You just have to get a general idea of what's going on and recognize that there is a mirroring of the original and its inverse across this y equals x line. Okay. All right, I hope that makes sense. If there's any questions about this problem or any other problems in this review video, you just hit me up and email me and we can discuss it. That concludes this test 2 review, and again, this is not comprehensive. You need to go back and look at additional problems, whether it be the homework, the e-text, or our class notes. Okay, so don't just rely on this as your source of study. Please practice these concepts by looking at other resources beyond this review. Okay, all right, talk to you guys later, and yeah, just email me if you need me. Okay, bye bye.